for you. That'll help. So, all right, ready? So we're gonna get more viewer participation.
Oh yeah, it's over here.
Yeah. Right, Katie? Viewer participation. So, all right. So with these right here,
Liquid.
solid.
Oh my goodness, I'm gonna fail.
Okay.
Oh right, because the tectonic plates move in the liquid mantle.
Yes, and so these two are part of the mantle, right? But the mantle asthenosphere is liquid, right? It's magma. Yeah, it's magma, but it's like real, yeah, like I said, plasticky kind of magma. The lithosphere, meaning what? It's the plates, the plate tectonics, right? Tectonic plates. And then the crust is the outermost part of it. That's what we are on, right? Okay. So, you're gonna have a few of those here and there. Plate tectonics is the movement of plates on the planet, right? How do we know plate tectonics is a thing? Earthquakes, volcanoes. I mean, if you took Africa and South America, wouldn't they kind of go together? Pretty, yeah, they fit. So there's things in South America that are found in Africa because, what's that tell you? Yeah, they used to be together. Okay, hot spots. Give me an island chain that's a hot spot. Hawaii. And what's associated with a hot spot? What? Volcanoes. Hot spot is just magma coming to the surface of the earth. And then if it erupts underwater, it'll keep erupting and form islands. So Hawaii is a hot spot. Okay. The Galapagos is a hot spot. Things like that. Okay. Okay. Characteristics of plate boundaries. All right. So that one is. What's that one called? Divergent. All right. So what's happening in the middle here? What do we get? So the mid-Atlantic ridge, right down the middle of the Atlantic, is spreading. If it's coming apart in the middle, don't you have volcanoes underwater, right? Because the magma. So here it is. There's a plate, and magma's coming to the surface and falling over, and that makes new material, and it just keeps kind of doing that. With me? And that's the middle. That's a divergent plate. Okay. And then we have the two convergents. Okay, and to understand what happens with convergence, you got to have your plate types, right? So you have ocean plates and you have continental plates. Which one's thicker? Continental, right? So if an ocean plate runs into a continental plate, because that's thinner, what's the logical thing to happen? It's going to go under, all right? Which we call subduction, right? So at a subduction zone, because this is going down deep, what's going to come up to the surface? Magma, right? And if magma comes to the surface, what's going to form right here? Volcanoes, okay? You also you also have from that island arcs, right? What's the classic island arc we talked about? Japan. Okay. Not that you have to know it, but what's the massive volcano in Japan? It's an F word. Fuji. Mount Fuji. The Ring of Fire is that entire ring around the Pacific Ocean from Alaska.
Is it like a ring of hot spots?
It's a ring of hot. Well, it's no. It's where there's subduction zones, and you have plates, and so you have all these volcanoes. Ring of Fire volcanoes, right? Okay. No, not really. Okay, so we've got Japan. All right, a collision zone is just where a continental runs into a continental, right? And so if two plates smash into each other, aren't they gonna crumple? And that forms mountains, right? Like the Himalaya mountains. So India running into Tibet, China, right? Smashing up into it. And that's a collision zone. Make sense? All right, and then this one is what? Transform. So if we go to California, name that. You have earthquakes. So what's that? What do we call these?
San Andreas Fault.
Yeah, faults. So the San Andreas Fault is a great example. Okay, the closest one to Indiana, not that you have to know, it's called the New Madrid Fault. It's in Missouri. And that's why, how old were you guys when we had that earthquake?
I don't
What year
recall.
was it?
It was a lot, I mean,
I think we were like
Not that
We don't
much.
remember it, but my
very small elementary.
I remember it was the summer, I was like, whoa, I mean, everything was strange. But anyhow, that's why we felt it, because it's in Missouri.
I was either in first grade, kindergarten, or preschool.
So you guys were pretty young. Okay. Okay, so let's see. Anything on 4-1? Feeling good?
No, the divergent and the convergent and the island arc. Is an island arc not the same thing as hotspots?
So islands are formed by hotspots, but the way Hawaii is formed is like here's the ocean seafloor, all right, and we have these pockets of magma that kind of come up and break the surface of the ocean seafloor. And when they do that, they form volcanoes, and they keep building on each other until they pop through the top of the water, and then you get like Hawaii.
So
That's a hot spot.
is an island arc
An island arc is,
because of convergent?
it's because of subduction happening, because this is going down, releasing the magma, and that magma comes up, okay? Well, it'd be over here, because we're talking the ocean. That comes up and forms like an island chain right here at that subduction zone.
Subduction and convergent are the same thing, right?
Yeah, because there's two types of convergence. There's subduction and there's collision. And the difference is that
What's the spreading?
the spreading is divergence.
Okay.
Yeah.
And that makes volcanoes too.
There's volcanoes there too.
So,
Doesn't make volcanoes, there's volcanoes there.
what are the two types of convergent?
Subduction and collision.
And collision is what makes mountains, subduction.
Yeah,
is
so
what makes
you gotta think of the makeup of the material. If it's continental and continental, they're the same thickness. So one's not gonna give and go under. They're gonna collide and crunch. But the subduction, you have a thinner ocean, it's weaker, so it's gonna go down. Okay, I think that's the info that wasn't in there. Okay,
Which one is that?
the ocean one, because it's thinner, it's not as thick. Right. Alright. Okay, so 3 parts of soil, what are they? Okay. Sand, silt, clay. Alright. Weathering is breaking down of stuff. Right? And let me go ahead and just do all weathering and then I'll do erosion. So physical weathering is things from the environment. Wind, rain, stuff like that. Okay? Chemical weathering would be like acid rain. Okay? Or here's one. What starts primary succession? What are those plants called? those plants,
Lichen.
lichen. What do lichens secrete on the rocks? They
Cinnamon.
make the rocks into sediment by secreting an acid. That would be a chemical weathering process. Okay? So weathering is the breaking down of something. Erosion then is the, what's the word I want to use? The movement of something from weathering. Right? So if it's raining like it is now, weathering is eroding thing or weathering things, but then the soil from these newly tilled fields, where's the soil going? Into the water. If it rains hard enough, right? That's the difference between the two. Got it? Okay. Now we're ready for soil horizons. Okay? The first one's easy because it's O. Okay? Yeah, it's the organic layer. It's the stuff, if you're gonna dig a hole, you gotta push the dead leaves out of the way and the dead stuff before you actually see that topsoil. Okay? And we're gonna skip E. Okay? We're gonna go to A. A is topsoil. Okay, that's the nutrient layer, you know, you put your plants in, things like that. Below that one is the subsoil. Okay? And then this would be C. What would be C? Yeah, it's just the bottom layer. Okay? It's been exposed to things, but now it's buried. It's close to the bedrock. Okay? There's the, there really isn't a name for it. It's the bottom layer. It's the weathered layer, you know, because it doesn't get weathered anymore, but it's down there and it's just kind of there. Okay? So E I didn't put on the test, so you know what? Let's not worry about E. Okay?
The nutrients are richest in
Topsoil.
topsoil. What about organic?
I mean, it's not broken down yet, though. It needs to decompose. It's just there. So, okay, loss of topsoil. What practice around here causes loss of topsoil?
Tilling.
Tilling. Yeah, with this loose soil, it rains, it just makes a mud pit, and the creek looks even muddier, right? Compaction. What compacts the soil? Machinery, mainly. I mean, walking on it would. M-A-C-H-E. So that doesn't look right. Oh, we do. There we go. Okay. Nutrient depletion. So, doesn't farming don't plants take the nutrients out of the soil? Yeah. And so like I said yesterday, how do farmers keep their fields with nutrients? They put fertilizer, they buy manure or chicken poo, the stinky stuff that they put on their fields, lime and all that stuff. Okay? All right, anything on soil?
Is that all we have to know about?
Yeah, that is.
What even is silt?
Silt is just this fine material. It's not as gritty. It's in dirt, but it's if you took out the sand, yeah, it's more of the fine stuff. It's pretty small. I mean, sand's really big relatively, and then silt, and then clay.
Could you pick up like an individual piece of silt, like a piece of sand?
Yeah, they'd be really small. So. Okay, so we know sand, silt, and clay. These are related to porosity and permeability. What's the most porous? Sand is most porous, then silt, and then clay, right? And then how are they related to permeability? It's still, sand's the most permeable, silt's the second, clay is the least permeable, right? So if you're a farmer and you want to grow crops, what kind of soil do you want?
Mix.
You want loam, right? LOAM. You want a mixture of sand, silt, and clay. It's like 40-40-20. Okay?
Clay is 20?
Clay's 20. You don't want too much clay, but you want a little bit of clay to hold that water, right? And that's kind of the ideal. Well, because if it's too porous, you're not going to hold water, your plants are going to die. If it's too much clay, it's going to drown your plants. So, okay, and then soil texture chart. We good on soil texture chart? Soil texture chart?
Wait, yeah, but soil permeability affects.
Porosity. Permeability and porosity are direct, it's a direct correlation.
Is permeability just how it can go through it? And then porosity
Is how much space is in between the particles. It's the same, really the same. So, do I need to show you a chart?
What's infiltration test?
That's that test where we had the funnel, and we put the paper liner, and then you put the dirt, and then you poured the water and timed how long the water would go through it. No, it's just I'm reminding you about what permeability it is from what that experiment that we did. I'm just reminding you. So. Okay, soil texture chart. You good on that? Isabel? Okay, moving on. Factors that increase or decrease soil nutrients. So, if you have more organic matter in the soil, right, that's, well, I used this yesterday. Is it better to rake the leaves and get rid of the leaves or mulch them?
These protect the soil from.
And they add nutrients. So adding organic matter, you know, like the leaves, are going to help increase soil nutrients. Okay, moving on.
That's all.
That's it. That's all you need. There's not too much. Okay, ready for atmosphere? Top two gases. So, oxygen and nitrogen. N2O2. N2 is how much?
77%.
And 21. That's just a recall question. Okay, I know the recall. Nitrogen and oxygen, those are the top two.
Now, what are the percentages?
Can't remember if you have to know the percentages, but I'll give them to you. Okay, so characteristics. All right, troposphere is where our weather happens, right? That's the weather that we get. So that's what we're in right now. You go up to the stratosphere. What's in the stratosphere? Ozone. I mean, that's the main characteristic of it. The mesosphere it's where meteors burn up.
It's hot. Is it the hottest?
Well, it's because of the friction of the atmosphere that burns
Is
them up.
thermosphere the hottest?
Okay, thermosphere is the hottest. Okay.
It's
Thermosphere is the northern lights. And don't even worry about exosphere. It's not important. Okay. All right. So then if we go to the next bullet, we have the temperature gradients. So cold, hotter. All right. And if we do tropo, strato, mesos, thermo. Okay. All right. So as you go up in the thermosphere, what's it do? Does it get cooler or hotter? Okay, so it gets cooler. Stratosphere, hotter. Mesosphere, cooler, hot. Okay, which is super easy to remember, right?
Wait, so when you're ground
I'm going to explain it right now. Okay, so why does the thermosphere get colder?
That thermosphere is the hottest one.
I said that wrong. Troposphere. This is tropo. Why does the troposphere get colder?
Further.
Yeah, it's farther,
The core.
yeah, away from the Earth, right? The Earth itself is warm because it absorbs heat. You get further from the ground, it's going to get cooler. Okay. Why does the stratosphere get warmer? It's the ozone layer that makes it warmer. It's O3. Ozone is O3. So ozone makes it warmer. Okay. Why does the mesosphere get cooler?
There's no.
You're just farther from everything, so it naturally gets colder. Okay. And then thermosphere, you're getting the sun's rays. Okay, you're on the outer edge of the atmosphere. It's going to be naturally warm. Okay, and that's why it's warm. Okay, got them? Okay.
I know how they do it. I just don't remember why they do it.
Well, that's it. I just went over it. Farther away, ozone, there's nothing trapping the heat. You're really far from the planet, so it's just naturally cold. And then the last one's warm because the sun's rays are striking it. The heat from the sun is striking it. So. All right, moving on. Okay, wind. Cold, warm. Cold air, just a fundamental concept. Cold air,
I just couldn't understand.
that's what that's the, cold air rises, warm air sinks. So it causes this circulation.
That you said that backwards. You said cold air rises. and
I just say that backward?
Yeah.
Warm air rises, cold air sinks. Okay, so we've got warm air rising, cold air sinking, right? That's kind of your visual, right? Warm air is less dense, it rises. Warm air is more dense. I said that backwards. Warm air rises, it's less dense. Cold air is more dense, it sinks. Done. Moving on. Okay, adiabatic cooling and heating. So as this warm air rises, what's it going to do? It's going to cool, right? It's going to give off heat. And then we're going to have condensation, and what's it going to do? It's going to rain. Okay? Then, since that warm air rose, it warms up, and then what's it going to do? Sink, and that cold sinking air is dry because it's lost all its moisture. Okay? And that ties into where I'm going next. Okay? So we call this whole warm air rising, cool air sinking, adiabatic cooling, adiabatic heating. Okay? So as this warm air rises, what's it going to do? Cool, that's adiabatic cooling. As this cold air sinks, as it gets closer to the surface, what's eventually going to happen to it? It's going to warm, so that's adiabatic heating. Make sense? It's just the process of what that warm and cold air is going to be doing. All right? Latent heat release, when that warm air rises, it gives off heat. That's why it cools. That's why it rains. Okay? Next one, determine saturation point. Okay, if you have a chart and I say it's 70% saturated, what's the temperature? And over here, if I have temperatures like this, you're gonna do that and go straight across, and that intersection point will tell you the temperature at whatever percent saturation it would be. So 70% would be, we'll just say in that case 20 degrees. Okay? So that's that. We good? Isabel, you good?
Not in heat release, it's just the adiabatic cooling.
Yeah, that's just the heat. The warm air that's rising loses its heat and it cools condensation, rain. Yep, okay. Cells.
I was
Okay.
thinking about that when I was thinking about the Hadley cells.
Yeah, so what are these cells? Hadley. What are these? And then up here, polar. Okay? Now, processes. Equator, air's rising, it cools. What do we get of a lot of right here? Rain. Okay? Now, we have adiabatic cooling, right? And then as it goes down, we have adiabatic heating. What is found at these tropics?
Deserts.
Yeah, it's very dry, so you have deserts. You have deserts at that because of the falling dry air that's warm. Okay? So, yeah, and it's going to be the same with all the cells. That's basically the idea. But the classic concept when you learn about this, it's right here. How does it affect the tropics? How does it affect the equator? How do cells do that? Okay? Good on those? Easy peasy? Okay, so now we'll do Coriolis effects. All right, in the northern hemisphere, so remember the Earth is going counterclockwise. Okay? In the northern hemisphere, what direction are things deflected? To the right. Or you could say to the east. Some people aren't good with directions yet, but you should know your directions. In the southern hemisphere, because of the Coriolis, it's left or to the west. That's the spinning and the apparent movements, right? So if you're in Houston and you're flying to Detroit, okay, I'm in the northern hemisphere, what direction am I going to be deflected? To the right, right, or the east. If I'm in Sao Paulo, Brazil, and I'm going down to southern Argentina, I'm going to be west or left, right?
So what happened to the middle one? Because it was east, west, east.
Well, no, this is just the Coriolis effect, the deflection thing. Now we're going to do the wind currents. Okay, this is just what happens to things and how are they deflected on the planet because of the Coriolis. Now we're going to talk about the wind patterns. Okay? All right, so let's do this. All right, so wind patterns. Okay, so let's start with trade winds. Trade winds are where? Trade winds are right there, right? TW. Trade winds come out of the east and go to the west. Okay? Westerlies are out of the west and go to the east. And then, of course, easterlies out of the east and go to the west. There's your wind patterns. Okay? So, because of the Coriolis effect, when the Earth spins, what part of the Earth is moving the fastest? Is this part moving the fastest, or is this part moving the fastest? Who remembers that one? The spinning effect. It's not the wind, it's on the equator's moving the fastest. The farther you get from the poles, the faster things are moving. Up here, things are moving really slow. Down here, things are moving really fast. So things covering more. Yep, that's exactly it. And yeah, and it's faster because they're covering more area at the same time. Yes. Yeah, that's new from yesterday. You notice I added that? So,
Okay,
I've added a few new things. Yeah.
Easterlies, why is the arrow moving west?
All right, remember they're named based on what they come out of.
Okay.
That's how you look at it. Yeah. So people who sail and know that's just the lingo. So, just how it's done. All right, good. Yeah, moving on. All right. So, wind patterns. 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 So, wind Watersheds. Okay, watershed. It's where water drains. That's it. Don't make it hard. Okay. Wildcat Creek drains into the Wabash. Wabash goes into the Ohio. Blah blah blah. Okay. Things that can affect drainage. Okay. Vegetation is going to decrease drainage. Right. Remember the crumple lab we did with the crumpled paper? The little felt pieces soaked up the water. Like that's what vegetation does. It decreases drainage. A slope is going to increase drainage. Well, soil permeability depends, right? If you have a sandy soil, it's going to decrease it. But if it's a clay soil, it's going to increase it. So it depends on what the soil is made of, okay? Impacts on watersheds, okay? So if you have, this farmer has hogs, the hogs poop everywhere, it always rains, where's the poo go? Goes into the water, algal blooms, all that bad stuff, kills the fish. If you have factories that are near the watershed, it's going to put stuff in there. So ways to improve watersheds, what should you have along the banks of the water?
Vegetation.
You want vegetation. More vegetation, less cement and pavements, right? And then of course there's other things that we're not going to get into yet that farmers can do to protect the water and things like that. But those are kind of your basics of watersheds. And that's it. Okay? Okay, solar radiation. Okay. Okay, out of these three lines of latitude, which has the greatest insolation? Equator, 0. Insolation means take in as much heat and warm up. Because why? Because it's most direct. Remember, the Earth is tilted, right? So these are going to come in at an angle. These are going to come in at even a greater angle. That's why it gets cooler as you work your way up. There's not as much insolation because the sun's not as direct. Okay? Albedo basically means whiteness, right? So give me an example of something that has a high albedo. The snow. Snow is high. Give me something right out there that's low. Pavement. Blacktop.
Wait, okay. High albedo means it reflects?
Yes, whiteness. The whiter it is, the higher the albedo. The darker it is, the lower the albedo. Yes. So why are the poles, they not only have less insulation, but what's their albedo? The poles. The poles are low because what are they covered with? Snow, so they're reflecting all that, right? But climate change is changing that. That's a whole other story. Okay, seasons. Okay, we have the sun. Okay. What's the season? We're talking northern hemisphere legal. This is summer. Summer solstice. This, what comes after summer? Fall. Remember, everything goes counterclockwise. So this is fall. Fall equinox. Equal. Over here is winter solstice. And then over here is spring equinox. Okay, remember we're going this way. Okay? And you're just gonna have a couple basic questions about
Wait,
that.
okay, can you explain that solstice equinox?
Solstice just means a certain hemisphere is receiving the greatest amount of light. So summer we are in the northern, in the winter the southern hemisphere is. Equinox is equal, you're balanced and there's an equal amount in northern and southern. For
Summer solstice, fall equinox, winter solstice.
yeah, summer, fall, winter, spring, repeat.
Solstice, equinox, solstice, equinox.
Yeah. So solstice, equinox, yes. Okay, here we go. Climate and latitude. All right. As you work your way up the higher latitudes, what happens to the climate? It gets colder. Yeah, it's kind of a no-brainer question. Okay. I'm gonna move this down to here, so we're gonna skip that for now. Okay, gyres. All right, gyres are, remember I did the little trash thing, circular patterns in the ocean. In the northern hemisphere, what direction do they move? Clockwise. Okay, northern hemisphere, clockwise. Southern hemisphere, counterclockwise. Just circulating currents in the oceans. Northern hemisphere is clockwise, southern hemisphere is counterclockwise. Okay. Upwelling. Think of like the coast of South America. What's coming up? Cold, high nutrient water. What's that create? Productive fishing. Yeah. Okay. That's upwelling. Okay. Thermal haline circulation. All right. So the warm currents go up north. What do they do? What do they do up here? They cool and come back down. So this warm current cools, and what do we know about cold things? They sink. So now it gets saltier, right? Because the salt is down there with the dense cold water, and then it circulates, right? And thermal haline circulation can modify climates, right? So if you're in Britain, why isn't it freezing cold like in northern Canada? Yeah, so right here is Britain. And that's Great Britain right there. It should be really cold, but because this warm current's going right by it, it kind of gives them a temperate climate. Okay. Upwelling, remember the lab where we blew the fan? You weren't here for that? Okay. High nutrient, cold water coming up with all this food, it brings the fish.
High nutrient cold water going up?
Yeah, this water is at the bottom of the ocean, but because winds are passing over the water, it brings that water, that cold, high nutrient water up, which brings the fish.
I thought cold water sank.
Yeah, but the winds are bringing it up because the winds are blowing over the water, which does this to the water, and it comes up.
So it's just bringing fish.
It's bringing nutrients, which then the fish arrive, and then fishing is good. Okay, rain shadow. Okay, so we have the ocean, we have a mountain, okay? All right, so warm, moist air comes off the ocean, hits the mountain, what's it do? Rises and cools, and then what do you get? Rain. So this side is the wet side. It's also called the windward side. That air is dry. It goes over the mountain. So what tends to be on this side of the mountain? Desert. That's called the leeward side. Okay. Windward receives the wind. Leeward is the other side. Okay, that's the mountain effect, or rain shadow. So, okay, good on that? Okay, last part, and we are done. Okay, so El Nino and La Nina. All right, so I'm going to. Okay, so here is South America. Here is Australia. Okay? If it's an El Nino year, winds are blowing where? Because remember, this is where the trade winds are. Normally the trade winds are doing this way, but now they're going this way and they're warmer. Okay? So we have lots of precipitation over here.
I'm sorry, I thought. Are we going up the earth from the other way?
Up here's North America. Australia's way over here, but I made the Pacific Ocean, so I shrunk the Pacific. Okay. So we have more precipitation here, but you have no. Oh, I can't spell. I'm trying to hurry. You have no upwelling. You should have upwelling right here. You don't have upwelling because the wind is going that way. Okay. Over here in Australia, because all the precipitation's here, it's cooler and dry, and that's an El Nino year. Okay. Now, if I do a La Nina year, okay, South America, I'm trying to hurry. Okay. Now you have strong trade wind currents, stronger than usual. So over here in Australia, it's excessively wet, but because the winds are passing over the water right here, you have awesome upwelling, which makes fishing really good during a La Nina year. Okay, that's the difference. Okay, normally we have upwelling and the winds are going this way, but La Nina is like bonus. The winds are stronger, better upwelling. It's even wetter in Australia and Southeast Asia. That's the difference.
So the upwelling, it doesn't affect Australia's upwelling?
No, we don't talk about upwelling in Australia. It's just mainly South America right there. So when we talk about Australia, it's
So
either going to be drier or it's going to be wet.
trade winds are weak for El Nino and trade winds are strong for La Nina.
Trade winds go the opposite direction during El Nino. During La Nina, they're stronger going their normal westerly direction. That's the difference. See how they're going to the right? They're supposed to go this way. They're going this way. Okay, but see I have double arrows here, made it really strong. Okay. What do you think, guys? Or did you do other things? Okay, so got a double review.
Okay, climate and latitude, mountains and oceans, 4.8. It's on. I was still writing stuff down LinkedIn.
When you do that coloring thing, you'll see that other part. Climate and latitude, it's just there's the line of latitude. It's really warm. Now we're getting farther from the equator. What's happening to the climate? Yeah, it's getting cooler. Mountains and oceans, that's actually this. Clockwise in the northern hemisphere, that's a circulation, and in the southern hemisphere they go counterclockwise. Clockwise in the northern, the water is circulating that way, right? Okay, I'm gonna throw these out at you, right? If an ocean plate runs into a continental plate, subduction.
Volcano.
What do you get? Volcanoes. What else do you get right here? Magma, which forms island arcs. Okay, these curvy islands. Japan's a big one, but there's little ones. Like, if you ever learn about World War II, all the battles in the Pacific, there's all kind of island arcs that they killed each other on. Peleliu was really bad. Have you ever heard? What if you have this? Transform. What do we get there? Earthquakes. Yes. Okay. Which layer contains the ozone? Stratosphere. Which layer do we exist in? Troposphere. Give me the main two gases in the atmosphere.
Nitrogen and oxygen.
Right. Because of the Coriolis effect, what direction are things deflected in the northern hemisphere? To the right or east. In the southern hemisphere, west or left. Same thing. Okay? What is the least porous soil material? Least porous. Clay. Okay. Which one of these letters represents topsoil? A. Which one is, it's no longer being weathered anymore, it's close to bedrock? C. Erosion. What, it's moving something, whereas weathering is,
I knew that.
Breaking it
Give
down.
me a second. I'm not good.
okay. Why is Hawaii a hot spot?
Volcanoes.
Yeah, indirectly, but what's making that?
What's it called?
The magma at the surface.
Subduction?
Okay, think of this. You have this crust, and you have the magma's
Hot
so
spots.
close. The magma's so close, it makes a hot spot. It makes it hotter than normal. That's why it's called a hot spot. And then it breaks through and makes volcanoes and all that stuff. Which one of these represents the tectonic plates? Lithosphere. What's the makeup of the core?
Solid.
Solid. Yeah. Okay, there's your quiz. So. Okay.
I'm so scared.
When you do that coloring thing, you'll work together.
The thing that I don't know the most is the divergent.
Oh, the plate boundaries. Just go through that. Open up those notes and just go through it. I mean, every slide is convergent.
I think I can get it. It'll take me
You
a
just gotta
while.
get it in your brain. Well, make sense of the words. Take the words and go converge. Convergence come together.
Collision, mountains, subduction, volcanoes.
Yeah.
Submarine, it goes down. Subduction.
Sub.
Well, I was thinking subduction because it's This one's
Do you want your phone?
Oh,
You're not gonna do it?